So today's lesson, we're going to go over the fundamentals of angle relationships. So a lot of definitions here, y'all. So angle, it consists of two different rays with the same endpoint. Side of an angle, it's an angle. In an angle, there are rays that are called the sides of the angle. So in other words, what do I mean by that? So that means I got a ray here and I got a ray there, and that's what creates my angle. The vertex is where the two angles come together. So that's this right here. That's what we call the vertex. We're going to talk about how to name angles. Interior angles, obviously what's inside, that would be all of this in here, right? That would be the interior of the angle, and then everything out here would be the exterior of the angle. We're also going to talk about how to measure angles with a compass, with a protractor. And then you should remember acute angle, which is between 0 and 90. Right angles is 90, and an obtuse angle is between 90 and 180. Straight angles has a measure of 180 degrees. Basically, it's a line. Congruent angles are angles that have the same measure. An angle bisector is, let me draw an angle again. So if I have this angle right here and I bisect it, and let's just say this was 60 degrees and I bisect it, means I cut it into two equal parts, right? So that would be 30 degrees there, and that would be 30 degrees there then, those two angles, that one and that one, right? Protractor is a tool that we use to approximate the measure of an angle, and a degree is the unit of measure for determining an angle, okay? So, again, an angle is formed by two rays with a common endpoint called the vertex. So our vertex down here is this R right there, okay? We can use a protractor to find the measure of an angle in degrees. And when we name an angle, we can name it several ways, okay? So we're going to talk about that. By its vertex, which would mean that this is angle up here, angle R, right? Because that's what the vertex was. We can name it by the points that are on the ray in the vertex. So we could name it angle S, R, T, S, R, T, or we could name it angle that go the opposite direction, right? T, R, S, like that. All right, or we can name it by what's inside it, right? The number that's inside of it. So we could also say it's angle 1. Right there where that 1 is, okay? So those are the different ways that we can name an angle. And we're going to use this symbol. Let me just make it clearer. It really should be straight on the bottom, y'all, and then like that. That's an angle symbol, okay? And we're going to use that a good bit. So you should know what it is. So it says you try naming. Now, name all of the angles in the picture. Now, I'm going to tell y'all right now that there are 8 different angles in this picture. So I'm going to give you guys a second to do it, and then come back to me when you're done. Okay, so our first one here is this big angle right here, ABD, right? So we could call that ABD. Oh, actually, let me put the angle symbol. Angle ABD. We could also name it the opposite direction, right? So angle DBA. Notice that the vertex is in the middle, okay? Then we could name this angle right here, ABC, right? So that's angle ABC, and again, we can go the opposite direction, angle CBA. Then we got this one right here, CBD, right? So that's angle CBD, and again, go the opposite direction, DBC. Okay, and then our last two are the ones that are inside. So we could say angle 1 or angle 2, okay? So those are all the different ways we could have named the angles. So a measure, the measure of an angle is given in degrees. All angles can be measured with the real numbers from 0 to 180. We use a protractor to measure the angles. So basically, if we are trying to measure an angle here, this would be how we'd measure it, right? We would go from there, and then if it went right up to here, notice you can tell that's an obtuse angle, right? So it's not going to be the 60 because that's not an obtuse angle. It would be the 120, right? So, and the other angle, if we were to go in the opposite direction, so if we were to go over here and to there, now that one would be a 60-degree angle, right? So 60 plus 120 is 180, right? So the inside measurement from 0 to 180 is counterclockwise starting at the right, and the outside measurement 0 to 180 clockwise starting on the left, okay? Hopefully you guys remember that an acute angle is between 0 and 90. Right angle measures 90 degrees. An obtuse angle measures between 90 and 180, and a straight line is formed by two rays that go in opposite directions and they measure 180 degrees. So anytime you have a straight line or straight angle, then it's 180 degrees. So the way that we determine whether two angles are congruent when we're looking at a drawing is they have these things called arcs, okay? So if two angles have an arc on them like that, then that tells us that those two angles are congruent. So in the diagram, the measure of ABC, the triangle or the angle on the left, and the measure of angle DEF are congruent. So they're equal. I should say the measures are equal. So we can write a statement that says angle ABC is congruent with angle DEF. This reads angle ABC is congruent to angle DEF. Arc marks are used to show that the two angles are congruent. So right angles theorem says all right angles are congruent. So if I have a right angle here and it was A, B, C, and I had a right angle up here and it was D, E, F, then those two angles would be congruent because it shows us that they have a right angle symbol. And hopefully you know that that little right square looking thing is what indicates to us that those two angles are congruent, okay? So now postulate, this next one is the angle addition postulate. So when we have two angles that are right next to each other and they share a side, then we can find the whole angle. So I'm going to give you an example of this. Okay, so let's just say that this angle over here is 100 degrees, right? And that this other angle over here is 20 degrees, okay? So the angle addition postulate says that we can take this 100 degrees and add it to the 20, and that would give us 120 degrees for the whole thing. So that's what this is showing us, is when we take an angle that's next to an angle, and we add them together, so angle RQS plus angle SQP is equal to angle RQP. So I do a part plus a part equals a whole, right? Okay, so now it says using the angle addition postulate, if the measure of XWZ, now that's the first thing we got to find. Where's XWZ? That's the whole angle, is 121 degrees. So I'm going to always do it like this with the whole big arc like that. So that tells me that that's the whole angle, 121 degrees. And then it tells me, so that was this one, that we have the measure of XWY is 59 degrees. So XWY is this right here. So that says this is 59 degrees. So notice that when we take the measure of the two angles, because it's asking us to find YWZ, right? So it's actually asking us to find this over here, okay? So what we want to do then is take those angles and add them together. So that means we're going to take our XWY, the measure of XWY, plus the measure of YWZ. And hopefully you guys can all see that that's equal to the whole big angle, right? Which would be XWZ. Okay? So if we use substitution, then we can say that the 59 plus the measure of YWZ is equal to our 121, right? So then what we do is we subtract 59 from both sides. And so we would do minus 59 here. So now we have 0 over there, minus 59 there. And when we do that, we get 62 degrees. So our big angle is 62 degrees. Sorry, the blue angle. My bad, y'all. Let me go ahead and change that. 62 degrees was this angle right here. And 62, and you can check that, right? So can't you just add those two together? If you add these two together, they should equal 121. And if they don't, then you know that you didn't get the correct answer. All right, so the next one says find the indicated measure using the diagrams below. The measure of DEG, again, we have the whole big measure. DEG is 115 degrees, right? Then we have DEF. DEF over here is 48 degrees, and then it's saying find FEG. So let's see if you guys can do this one. Pause me and come back to me when you're done. So this one, again, we would do 48 plus the measure of angle FEG is equal to our 115, right? So once again, we're going to subtract our 48 from both sides. So the measure, actually, let's do that in blue. The measure of angle FEG is equal to 115 minus 48. Trying to see if I can find that on my paper. 67 degrees. Okay? All right, let's see if you guys can do this one as well. Label it, and then go ahead and solve it. Pause the video. So DBA. So DBA is right there, so that's 23 degrees. CBD is 19 degrees. And then it's asking us to solve for the whole thing, right? ABC. So wouldn't we go 23 plus 19? Actually, let's go ahead and color code that like it is. 23 plus 19. That's going to be equal to what? What is 23 plus 19? 42? Yep, so our answer is 42. That's going to be the measure of angle ABC, and that's equal to 42 degrees. Okay? All right, angle bisector is a ray that divides an angle into two congruent or equal angles. So it says JK bisects angle LJM, therefore LJK. So bisects means what? That's what we need to differentiate here. Bisects means two equal parts, right? You need to remember that, okay? That means it cuts the big angle into two equal angles. So that means that this angle and this angle are congruent, and that would have marks on it like that to indicate arcs that indicate that these two angles are congruent, right? So let's just talk about what that means, okay? So that means if this was, let's just say 25, and actually let's do it this way. If I said that this whole angle was 44 degrees, okay? So then what would it be? What would each of the parts be? Wouldn't we divide them by 2? Yes, we would. So that means this would be 22 degrees and this would be 22 degrees, okay? Because LJM was bisected by JK, okay? So now, this says finding the measure of the angle. So it says QS bisects, key word. Let's circle that. That means that QS bisects angle PQR. Okay, that means that this angle and this angle are congruent. How do I know that? Because it said it cut it into two equal parts, right? So then it tells us that PQR, the big angle, is 8y plus 12. And then it says find the measure of PQS. So obviously we could set PQS equal to SQR. But what does that mean when we have the same measure twice? So doesn't that mean that this 5y minus 1 is there as well? So there's two ways we could do this. We could say 5y minus 1 plus 5y minus 1 is equal to 8y plus 12 because it's there twice, right? Or we could do 2 times it. Either way, we're going to get 10y minus 2 equals 8y plus 12. So we're going to go ahead and subtract the 8y from both sides. That's going to give us 2y over here. We're going to add 2 to both sides. And notice that went away from there. Now that's gone from there, and that's going to be equal to 14. Then we're going to divide both sides by 2, right? So y, remember we always do opposite actions. Okay, so now we have that y is equal to 2, but it's not asking us for y, it's asking us for the measure of SQR. So SQR is the angle we don't have, but the truth is it's the same as 5y minus 1, right? So the measure of angle SQR is equal to 5y minus 1. So that's going to be 5 times 7 minus 1. So that's going to be 34 degrees, right? Because 5 times 7 is 35. Yes? So this one's going to be 35 minus 1. So this is going to be equal to 34 degrees. So what if it asks us what PQR was? So that means if this is 34, right? That means that's 34. So what's the whole big angle, guys? Isn't it going to be 68 degrees? Okay? Any questions? And you can check that, can't you? Because what is 8 times 7? 56, right? 56 plus 12 is actually 68. So yes, again, you can check these. So to make sure you do. So now this last one we're going to draw, okay? So it says, you try 3A, draw the information, then find the measure of the angle. So we're going to draw. So we're saying, it's saying JK bisects. So we're going to draw this angle first, angle LJM. So we got L, and we got a J, and we got an M over here. It says that it's being bisected by JK. Okay, so what does that tell me? It means that's congruent with that because of that word bisect, right? Bisects means that those two angles have to be congruent. Then it tells us LJK is negative 10x plus 3. KJM is going to be negative 10 plus 21. And then it's asking us to find the whole angle. Now this time we're going to have to set up a little different, right? We're going to set those two angles equal to each other, right? So we're going to say negative 10x plus 3 is equal to the negative x plus 21. So I'm going to add 10x to both sides because I don't like negative numbers. So I'm going to go plus 10x plus 10x. So that's gone. So I've got my 3 still left here. On the left, 3 is equal to, and that's going to be 9x because that's 10x minus 1, right? Plus 21. So now we're going to subtract the 21 from both sides. So minus 21, minus 21. 21's gone from there. So 21 minus 3 is 18. So 18, so it's going to be a negative 18 is equal to 9x. And then we're going to divide both sides by the 9, right? Because when you always do the opposite operation, right? So that means x is equal to negative 2. Now, we're going to plug that x back in to find the measure of our angles, okay? So we're going to do it right here first. Actually, let's do it in LJM, yeah. We're going to do it in that one first, and then we're going to do it in the other one just to double check our answers, okay? So we're going to do negative 10 times 2 plus 3 times a negative 2, sorry. So that's going to be 20 plus 3, and that's 23, right? So I'm going to go ahead and put 23 degrees right there. Now, the other one should be 23 degrees as well, right? So here again, we're going to say minus a minus 2 plus 21. So what's minus a minus? It's a plus, right? So that's going to be 2 plus 21. So that's also 23 degrees, right? So we're going to put 23 degrees right there. Now, remember, it's asking us for the measure of LJM. So what do we have to do with this 23 and this 23? Yes, we got to add them. 23 plus 23 is equal to 46 degrees. And that is our answer. Okay? Let's see if you guys can do this one. Draw it this time. Let's see if you guys can draw it by yourselves and then come back to me when you're done. All right, so on this one it says JKL. So I'm going to draw a J. And how you draw these doesn't really matter as long as you label it correctly. JKL, okay? And then this one again is being bisected by KM. So the M's on here. And if it says that it's in the interior, if there's a dot on the interior, y'all, then that's what it means, that you're placing a dot in there and you're going to draw a ray, okay? So once again, if it's being bisected, that tells us that this angle and this angle have to be congruent. So it says JKM. Oops, I forgot to label the M. JKM is 4x plus 6. And then we have MKL. MKL is down here, 7x minus 12. These, again, are going to be set equal to each other, right, because they are congruent. So we have the 4x plus 6 is equal to the 7x minus 12. We're going to subtract 4x from both sides. So the 4x's are gone from there, so that leaves us with 6 is equal to 3x minus 12. So we're going to add 12 to both sides to get rid of the 12 on the right. So that gives us 18 is equal to 3x, right? So that's gone from there. Going to divide both sides by 3. So x is equal to 6. Now, once again, it says find the measure of JKM. And JKM this time is only this angle right here, right? I'm going to do it in a different color. JKM is right there, okay? So we're going to put it into that formula. So 4 times 6 plus 6, so that's 24 plus 6, so that's 30, is equal to the measure of angle JKM, okay? Now, what do we know? Those two should be equal, right? So if you want to double check to just make sure your answer's right, then you could do 6 times 7 times 6, that's 42, minus 12, guess what? That's 30. And that's what we were expecting, right? 30 degrees. And again, if it asks you about JKL, you could do 30 plus 30, and that's 60, right? Okay? So you got to look for those words bisects, though. Okay, so then we're going to talk about adjacent angles. These are two angles that share a common vertex inside but have no common interior points. Okay, so what does that mean? That means this angle right here and the one beside it, they form a line, right? They don't always have to form a line, but this is what we call a linear pair. We're going to talk about that some more tomorrow. But supplementary angles are two angles who have a sum of 180 degrees, whereas over on the right, we have two angles, 60 and 30, that add up to be 90. Okay, so if I were to ask you to go ahead and draw another pair of angles that are supplementary, you could do one that's like 20, right? And then 20 plus what is 180? So you could say 20 plus 160 is 180, right? So those are supplementary angles. If we were to do another example over here, we could do what? 45 and 45, because 45 plus 45 is 90. Now, an easy way to remember these guys is that 180 has an S in it, and it's supplementary. And 90, which is complementary, and that has a C in it, okay? Those are easy ways to remember them, supplementary and complementary. Supplementary is 180, complementary is 90. Because remember, you guys got to remember all this stuff. There's none of it on a formula sheet. So this one says congruent supplement theorem. So basically, this tells us if angle 1 and 2 are supplementary, then angle 2 and 3 are supplementary. And what that means is, so if I had some angles like this, and this was 1 and this was 2, right? And I told you that I had another angle over here, angle 3, and I told you that angle 1 and 2 are supplementary, and 2 and 3 are supplementary, then I could say that angle 1 has to be congruent to angle 3. Y'all see that right there? They have to be. Okay, so what would that mean? That means like if this was 40 and this was 140, right? Then this would also have to be 40 if that statement was true. And the same thing is true with complementary, okay? So once again, let's just say that we had a 60-degree angle and a 30-degree angle. And let's just say this one was 60 and this one was 30, right? So that means that this is 30. And if they are complementary, then that means this one has to be 60. Do you guys understand? Okay.